So I've been working the last few months on these mazes, and they're mazes that print entirely in Vase Mode. That means that they print the entire thing without doing any kind of retractions, and they follow the outer contour of like the STL you provide. I'll talk about that more later, but I use two pieces of software to generate these. I use Daedalus, which is a somewhat old open source maze generation software on steroids that has a ton of it has a scripting language and a ton of really awesome features. And then the other is OpenSCAD, which is a free and open source CAD system that's more like a scripting engine instead of like a conventional CAD system like Fusion 360 or SolidWorks or something. And I wrote a script that basically talks to Daedalus, and then it generates the mazes, and then it converts the output of Daedalus to an OpenSCAD script to generate the STLs. And in my script I can specify the width and the height and what maze generation algorithms I want to make the mazes. In fact, I can just press one button and it'll make all these different beautiful mazes here. This one, for example, is recursive backtracking. In my opinion, it's the most fun to play with because it makes all these long windy paths and stuff. And then this one right here, this one is Prim's algorithm, which I find is more difficult to solve than any of the others because it creates all these really short dead ends. It's hard to get the marble to hop into this, or to make the marble go where you want it to. And then this one here is True Prims. It's very similar to Prims. Anyway, there's like 15 or so maze generation algorithms. Some of them, or not many of them, are worth noting, but I'll still go through them all here. This one here is Kruskal's algorithm. This one is Wilson's algorithm. This one is, just looking at my notes here, this one's Eller's algorithm. This one is Growing Tree, which is actually the same thing as Growing Forest, which is this one here. The Growing Tree and Growing Forest are kind of the same thing. And then this one is Recursive Subdivision, which basically it like cuts the things in half as it goes down. There's also a few weird ones, like here, this one is known as Binary Tree, and as you can see, all of the pathways all branch like this. It's actually really difficult to get the marble to go down to the very corner here, so yeah. And then this one here is called Sidewinder. It's very similar to Binary Tree. Then it also generates some other things, like this is called Spirals, where it makes all these really dizzying spirals that are hard to follow. And then this one kind of biases all the pathways so they go along diagonals like this. This one's real trippy to solve when this one isn't very interesting, but if it was bigger I think it would be real hard to solve because you couldn't really follow anything. And then this one here, it kind of biases all the pathways to being horizontal. Actually, I think they're biased to being vertical. I can't remember how it was generated, but yeah. Now I took very, very heavy inspiration from Oscar's maze, or Oscar's fractal maze, which is here, this one. And he made a video about 2 years ago where he made this exact fractal maze, and he made it such that it printed in Vase Mode. Well, I could never get his file to slice or to print properly, so I took it upon myself to basically just reinvent his wheel. I did a lot of things differently, as you'll see in the CAD system, but I wanted to personally credit him and to link to his video up in the corner here. And this is just his maze. It's really difficult, it's really dizzying to look at, but it's a lot of fun. I've solved it a few times. Anyway, Daedalus, let me find the right ones here. Daedalus also supports scripting, so it allows you to specify any shape of the maze you want, and with the help of Walter Poland, the creator of Daedalus, I was able to make a diamond shape like this, which I can actually use a lot of these algorithms. I can't use every one, but I can print any one of these algorithms in a diamond shape like this, and it looks cool. And then there's also this one here, which is known as unicursal. It basically has no dead ends. It goes from here to here, and it zigzags through every cell in the maze. And along the way, it visits every cell in the maze. This is actually my sister's favorite one to play with because you can go real fast through it. You don't have to think about where to stop and pick forks in the road. And I think this would actually be fun as some kind of a speedrun competition where you try to get the marble to go as fast as possible through these pathways. Yeah, I don't know. And then this one here was printed in an algorithm called Cavern, and Cavern just makes the pathways kind of go off grid a bit. Anyway, that's everything I can make with my script. I'll head over to the CAD system and show you how printing these in Vase Mode even works, because in my opinion it's quite impressive. Anyway, I'll see you there. So now that we're over at the PC, let me just discuss kind of what my script actually does. Now this is an example of a command. It just kind of runs this. It lets me specify the width, the height, and the algorithm that's being generated. Now this is prim2. This is actually TruePrim's algorithm, but prim2 is what Daedalus calls it internally. Anyway, if I run it here, it invokes Daedalus and it just passes those 3 parameters to it, and it makes the maze 47 or 48 by 48 pixel maze with prim2, or with TruePrim's algorithm out here. Now I won't be discussing much about this, about Daedalus. I think that's outside the scope of this video. But you can just make sure that there's no bugs that happened in the generation process. There sometimes is, but not all that often. And you can just close it, because, or when you close it, it actually generates the it generates the text files, and then my script converts it to OpenSCAD script, or OpenSCAD stuff that OpenSCAD can read. And that's what this garbage here, it's just the way OpenSCAD formats an array basically. And I just have that, I have the maze stored as a 2-dimensional array here. And then if I open my OpenSCAD script here, it's tongue twister, I know. You can see the maze pop up. It takes a couple seconds, but boom, there's the maze with these near invisible pathways. I'll go over that more in the slicer thing, but there's a ton of parameters here. I did have a section where I discussed all these, but I'll leave that for a tutorial video that'll make at a later date. It ended up taking a bit longer than I expected. So you can just inspect this and make sure everything looks okay. And I press F6, it makes a little ding sound that just means it's done. And what that does is it tells OpenSCAD to just say, hey, make the STL. And now I click File and Export STL, and I just save it as whatever. Let's call it maze1.stl, and then I click Save. So now I'm going to hop over to Cura now. See, Cura is just launching, and the maze comes right in. So this is a 3D model of the maze we just generated. As you can see, the paths are barely visible on the top. I'll get more into why that is later. And from the bottom, you can see the maze is just pure, or clear as day. Anyway, if I click Slice here, and then I click on Preview, so you're looking at the G-code now. Like magic, the maze just sort of appears. And you may be asking yourself, well, why is this? Well, I have Vase Mode turned on. It's also called Spiralize Outer Contour by Cura. But the thing about, or a quirk of Vase Mode, is that if you have any surfaces of your part and they're perfectly parallel with the top, or perfectly parallel with the build plate, then Vase Mode just kind of pretends they just don't exist. And so that's really what's going on here, is that you're seeing the path the G-code preview of this, and you're literally looking around on the inside, looking through the top of the part to the inside of the part. And normally this would draw a singular line around your part, creating a really smooth, kind of beautiful, kind of shiny surface to it. But I came up with a really neat trick, and how it works is, if you remember that old adage of how if you're stuck in a corn maze or something, then you should always hold your arm out and then hold your arm to the right side of the maze. So like if you ever turn, you're always supposed to, or if you ever meet up at a junction, you're always supposed to turn right to change, or so you like always follow around the maze. So the reason why that works is because eventually, if you do that, then you'll walk around the entire outside of the maze, and you'll eventually find one of the exits to it. Maybe there's only one exit, depends on the corn maze. But anyway, that's exactly what the slicer's doing here. And so what the slicer is actually doing is, if we step down to one of the more clearer layers here, the slicer is going around the entire maze and following just the right side of the, like following the right side of the inner side of the model. And if we just go through here, I just running the G-code preview here by running, or by holding right on the arrow keys, then you can see it's sort of like magic. The Vase Mode is just drawing the maze, and it's somewhat miraculous that this even works, because you have to have some pretty advanced pathfinding algorithms for the maze to even come out like this. And what this does is that there's no travels and there's no retractions ever when it's printing the maze. And one of the problems I found is that if there ever is, then it'll leave like little tiny microscopic hairs that normally wouldn't even matter for prints, but the hairs would block the marbles from rolling around and make it not so much fun, because you'd have to like pick them out with tweezers or something. But anyway, with this method, none of that happens, and the maze comes out absolutely beautiful. And the walls you're seeing here, they're actually, let me just switch over to preview here. They're actually extremely thin gaps in the model. They're actually 30 micron wide gaps. And I found that if I made the gaps any smaller than that, then both Cura and Prusa Slicer would just completely ignore them, and it would actually end up printing a solid part for some reason. By the way, Cura, please fix this. It'll make my mazes print better. Anyway, that's really about it. There's some more technical stuff, like how I draw this this line going on the wall here, but it's really quite technical for how that works. It still uses the same trick of like the outside. The outside of the part is actually this tiny little gap here, and then it goes around here, and then it circles the entire maze. But apart from that, that's pretty much everything you need to know about how it prints. So the thing is that the walls of the maze are actually gaps, and they fuse together because of just general over extrusion and general inaccuracies in the 3D printing process, and that because they fuse together, they make somewhat of a durable part that you can play with without it flying or without it just breaking apart in your hands. Now, I want to give Oscar van Deventer a huge shout out, because I essentially copied his design from scratch. He made this maze here. He calls it the Mega Maze, and it too prints in Vase Mode, but I could never get his file to actually print. And so that's what led me down this huge rabbit hole. And then I found out, or I figured out, it was almost trivial for me to just manually enter some other maze besides his. Actually, entering some other random maze is easier, because this is really, really hard to look at. So I just want to give a shout out to him, because I did copy his system a little bit. I literally turned it inside out, but apart from that, it's his design. And I will be linking to the video he made on his maze a couple years ago, called just the Oscar Mega, or I think it's called Oscar Mega Maze. Yeah, I'll link to it at the end of the video. And I will be open sourcing all of the stuff I developed for generating these. However, I just want to give a short warning that it's very convoluted to set up. Like, you need to have an install of Linux just to run my script, because that's just how I wrote it. No interoperability in mind. And then the other thing is that you need quite a beefy computer just to run the OpenSCAD script, because it uses this thing called Minkowski summation, and that's really, really computationally intensive. I'll still leave them up, and then for anybody to look at and poke at it, it'll all be under the GPL license. Anyway, I'll cut the video end here. Cut the video here. It's getting kind of rambly. Thanks for watching.